Here I have two different versions of the double angle identity for cosine. Let's start by looking at cosine of 2x is equal to 1 minus 2 sine squared x. So the idea here is that I want to isolate sine squared x. So what I'm going to go ahead and start by doing is I'm going to go ahead and add 2 sine squared x to the left side of this equation and subtract cosine 2x to the right side of this equation. So I'm going to have 2 sine squared x is equal to 1 minus cosine of 2x. And the reason why I did that is because I wanted this to be a positive term. So I wanted to add it to the other side to make it positive 2 sine squared x and then 1 minus cosine 2x. And again, my goal is to isolate sine squared x. So I'm going to next divide both sides by 2. So I have sine squared x is equal to 1 minus cosine 2x all over 2. And that is the power reducing formula for sine squared x. So that takes sine from a power of 2 down to an expression that involves the cosine function to the first power only. Now it does have an inside of 2x instead of just x, but the goal was to reduce the power of sine from sine squared down to a trig function with only a power of 1. An alternative way to think about the right-hand side of this is to think about this as 1/2 minus 1/2 cosine of 2x. So what's happening there is taking the first term and dividing it by 2, and taking the second term and dividing it by 2, or thinking about it as 1/2 in front of cosine of 2x. So both of these are equivalent versions of the power reducing formula for sine. Now, if we take this other version of the double angle identity, cosine of 2x equals 2 cosine squared x minus 1, I'm going to try to isolate cosine squared x now by first adding the 1 to the other side, since 2 cosine squared x is already positive. So I'm going to add 1 to the other side. Cosine of 2x plus 1 is equal to 2 cosine squared x. Then I'm going to divide by 2. So I have cosine squared x is equal to cosine 2x plus 1 over 2. I'm going to choose to write that as 1 plus cosine 2x divided by 2. Since addition is commutative, I could switch their places just so I could kind of see side by side how the power reducing identity for cosine, so cosine squared, becomes 1 plus cosine of 2x over 2. And the power reducing identity for sine, so sine squared, was 1 minus cosine 2x over 2. And then I can also do that same thing and think about this as cosine squared x is equal to 1/2 plus 1/2 cosine of 2x. So to wrap up, you might be wondering, what is the point of this? Well, there are certain circumstances where we would rather be working with a trig function raised to the first power than working with the trig function raised to a higher power. So this is a tool that we will be able to use to reduce the power of a sine or cosine function